Hello everyone, let's do some more IUPAC nomenclature problems today. Today we are going to look at different types of structures, cyclic compounds, compounds with multiple cycles, compounds with multiple functional groups, and unsaturation. So a mixture of problems will be there for us to solve today. So without wasting any further time, let's get started with the first problem. We have a bond line diagram here, and our goal here is to write the name of this compound. Alright, so using our step-by-step approach, the first thing we do is to identify the functional group. You can see that in this compound, we have a functional group, that is the OH group here. So this compound's name will end in an OL. We still need to find out the position of this OH group, but we will do that in a later step. Moving on, the next step is to find carbon-carbon double bonds or carbon-carbon triple bonds. Well, there are no carbon-carbon double bonds and carbon-carbon triple bonds in this compound. We will write AN in the name. Both of these contribute to the suffix part of the name. Okay, now that we have that out of the way, let's look at the parent chain. Since we have a cycle, so when there is a cycle present in a molecule, we try to see if we can make that our parent chain, and we can highlight it like this. Okay, there are 6 carbon atoms in this cycle, so this will be a hex, and since it's a cycle, so we will call it cyclohex. Next up, substituents. Now you can see that the compound has 2 substituents, and both of them have 1 carbon atom each, so they are methyl groups. Since we have 2 of those, we will call it dimethyl. Now where are these substituents located? For that, let's number this parent chain. When numbering the parent chain, we try to number the carbon closest to the functional group, the carbon atom 1. So we will call this carbon atom number 1. Then we have 2, 3, 4, 5, 6. As we can see, the position of the substituents is at carbon number 3. So we will call this 3, 3 because there are 2 groups. So 3, 3 dimethyl. Alright. So we have everything required to write the name of this compound. The name of this compound will be 3, 3 dimethyl. Then we have the parent chain part, which is cyclohex. Then we have AN, and then OL for the alcohol, and the position of this OH is at carbon atom 1. So cyclohexane 1 ol. You can choose to omit the position 1 from the name and simply write this also as cyclohexanol. That is also fine because the position of the functional group here is not ambiguous. What kind of a compound do we have here? We have a COOH group attached. So that means that this is an acid. So its name will end in oic acid. Now do you see a carbon-carbon double bond? Definitely there is a CC double bond present at this spot. So the name will also contain EN. Alright, moving to the parent chain. Now the interesting part in this question is that the functional group also has a carbon atom. In cases where there is a functional group with a carbon atom, then when finding the parent chain, we include that carbon in our parent chain. Also, we start numbering from this carbon atom. So we will say that our parent chain is this, and we number this carbon as the first carbon, then move towards the left. So 2, 3 and 4, and we can see that there are 4 carbon atoms in this chain. So this will be bute. The position of the double bond is at carbon atom 2. So if we include that as well, then we will write but-2-enoic acid. Okay, and we have a substituent present here, that is the methyl group here. So we will write 3-methyl because the position of the substituent is on carbon atom 3. So 3-methyl but-2-enoic acid. Let's look at the next problem. Once again, this is an interesting question because we have more than one functional groups present here. First is the COOH group over here. Then we also have a NH2 group. We also have an OH group present here. Now, whenever there is a compound with multiple functional groups, we need to decide the main functional group. And for this compound, the main functional group will be COOH. We followed the priority list of functional groups, and there the COOH group has the highest priority. And now let's count the carbon atoms in the parent chain. As discussed in the previous question, we will include the carbon of the functional group in the counting, and so we start from here, then move towards the left. Thus, we can see that the NH2 group is at position 2, which means we can say 2-amino. And the OH group is at position 3, so we will say 3, and OH as a substituent is called hydroxy. There are 3 carbon atoms in the parent chain, including the one from the COOH group. So it's a propane, and then we have the oic acid because of the COOH group. Next point to consider is when writing the name, we write the name alphabetically. So we will first write 2-amino, then 3-hydroxy, then propanoic acid. Many students make the mistake of writing from the left hand side, and they might write 3-hydroxy, then 2-amino, propanoic acid. And guess what? This might be in one of the options if this is an MCQ question, but the correct way to write is the alphabetic order, which is 2-amino, 3-hydroxy, propanoic acid in this case. Let's move to the next example. This time we have a cyclic compound. It's an alkane, and we are seeing the bond line diagram of this alkane. The interesting part is there are more than one cycles in this compound. Let's see what we do when there are more than one cycles present in the compound. The step 1 in this case is to find the common carbon atoms. You can see here that the common carbon atoms are located at this position, and we have another carbon at this position. These 2 carbon atoms are what connect the cycles together. Okay, that is the first step. Locate the common carbon atoms. Now we start numbering from these carbon atoms. Since there is no other substituents attached here, we can select any one of these, and then we move first in the larger part. So we can start from here, then we can go towards the larger part, and then come back. This becomes carbon atom 6. Then we complete the cycle like this. So we can see that there are in total 9 carbon atoms. So we will write nonane in the name. Okay. Now since there are 2 cycles here, so this compound will have a prefix called bicyclo. Okay. Then in order to figure out how to construct this compound, we write the number of carbon atoms in each path between the 2 common carbon atoms. I will repeat. we find the number of carbon atoms in each path shared by the or between the two carbon atoms that are common between the cycles. So, as an example here, you can see that there is one path that goes from the carbon atom 1 and follows this highlighted path. Okay. Then there is another path possible here, which is if you can start from here and take this route. And there is a third path possible, which is this direct path between the two carbon atoms. Okay. Now that we have decided the paths, we will count the number of carbon atoms in each path. In the path to the left, there are 4 carbon atoms. You can see them here. In the path on the right, we have 3 carbon atoms. And in the path directly connecting 1 and 6, there are 0 carbon atoms. In the path on the right, we have 3 carbon atoms. And in the direct path between the common carbon atoms, there are 0 carbons. So we write these numbers inside this square bracket, but in a decreasing order. So we will say 4.3.0. And the name of the compound thus becomes Bicyclo-430-nonene. Okay. Let's do another problem. What will be the name of this compound? Again, the first step is to find the common carbon atoms. We can locate them here at this spot and this spot. Start numbering. There is no substituent attached, so you can pick any of these carbon atoms as the carbon 1. Suppose we take this one. Both of these rings are the same, so we can move in any one of these. Let's move towards the right, and we can see that we reach the second carbon atom at position 6. Then we can continue in the other ring, and we have a total of 10 carbon atoms. Since there are 10 carbon atoms, the name of this compound will be decane. Now there are 2 cycles, so we will say bicyclo for 2 cycles, and then we will put the square brackets and then count the carbon atoms in each path. In the path to the left, there are 4 carbon atoms. On the path to the right, there are also 4 carbon atoms between these common carbons. And in the direct path, there are 0 carbon atoms. So the numbers that we write inside the square brackets are 4.4.0. And the name of this compound is Bicyclo-440-decane. Okay, look at this new problem and let's try to write the name of this compound. Once again, there are more than 1 cycles here. So let's first find the common carbon atoms in these cycles. Common carbon atom at this spot and the other common carbon atom at this spot. Now we can label any one of those as the carbon atom 1. Let's call this carbon 1 and move in the ring. So we can go to this 2, then 3, then 4. Then we can choose either of the paths because they are of the same length. Let's take this one, 5, 6. Okay. Then we have 2 more carbon atoms here, 7 and 8. So there are total of 8 carbon atoms. Thus the name of this compound will have octane. There are 2 cycles present, so we will call it bicyclo. Then we will put a bracket here and count the carbon atoms that are intermediate in each path. And in each path you will see that there are 2 carbon atoms. 2 octane. In the previous question, we saw 2 cycles are connected to each other with the help of 2 common carbon atoms. Two cycles can also be connected to each other with the help of a single carbon atom, which is what we see in this figure. In this compound, there is only one carbon atom that is common and that is present here. How do we name these compounds? Well, we can follow the similar rules that we use to name the bicyclo compounds. The only difference is that we will call this Spiro in the name as the prefix. Okay, so let's start by numbering these carbon atoms. The first carbon is the common one, which is here, so we will give it a number 1. Then we will move in the larger ring, so we can start from here, and we can see that in this path we encountered 5 carbon atoms. Then we can move in the smaller ring, 4 carbon atoms. Okay, so there is no third path over here because there is only one common carbon. Alright, so how do we write the name? There are 10 carbon atoms, so this becomes a decane. Then we have a Spiro compound because only one common carbon is present. Then we draw the open and closed brackets and then write the number of carbon atoms present in each path. So on the longer path we saw that there were 5 carbon atoms, then a dot, and on the smaller path there were 4 carbon atoms. So the name of this compound is Spiro 5,4 decane. Alright, final problem of the day. What do you think the name of this compound will be? It's a very interesting question because there are cycles present in the compound. The cycles are connected with the help of 2 carbon atoms, and there is also a functional group present as an alcohol. So how do we name this compound? In this case also, the first thing to do is to find the common carbon atoms. You can see the common carbon atoms between the 2 cycles as marked here. Now we will label all the carbon atoms, but this time we cannot simply select any one of the common carbons as carbon atom 1. We will pick that carbon atom as number 1, which will provide the lowest position to the OH group attached carbon. Okay, so if we choose the top carbon and start counting, we will reach the OH group carbon at position 3. And had we chosen the bottom carbon, then we could reach it at position 4. Since we want the lower number, so we will take the top carbon atom as our carbon atom number 1. Now we can just move around in this cycle and then complete the other cycle as well. After moving in the ring, we can see that there are 8 carbon atoms. So it is oct. There are no carbon-carbon single or double bonds, so it is octane. There is a functional group present at carbon atom number 3, so it will be -3-all. This is the usual naming part. Now let's get to the naming of the cycles. So we have 2 cycles here, so we will call this bicyclo. Then we will draw the square brackets. And now between the first and the 6th carbon, that is, which are the common carbon atoms, we have 4 carbon atoms on the right side, 2 carbon atoms on the left side, and 0 carbon atoms in the middle line. So the name of this compound will become 4.2.0 octane 3-all. So it's bicyclo 420 octane 3-all. Go try out some examples yourself. We will meet in another video. See you.